defining sustainable design is a big challenge, and everybody in this room might have a different opinion of what sustainable design might be. But from an engineering and a material scientist perspective, I would say sustainable design is something which is paying due respect to the ecological standpoint, to the ecological consideration of the design. So a design based on ecological principles. So what would be some key features of those? One would be zero to minimal environmental impact. And not only in the designing phase, but whatever phases Jason talked about, like transportation, extraction, in case of wood, logging, harvesting, things like that. So what impacts those have on the environment? What are the carbon emissions? What are the greenhouse gas emissions? We have to take those into account. The sustainable design should incorporate that and come up with a solution which will have minimum environmental impacts. Also, it should have a closed material loop, so the material should be recycled or recyclable, it should be reused. So the material loop should be closed, it should not be going into the landfills and creating a mess again. And also some end-of-life issues. So the design should be such that the product or the building, for example, should have the capacity to fully integrate into the landscape after the service life of the product is over, or service life of the building is over. So it should be designed for decommissioning, or designed for disassembly. So these are three things, I think: the zero environmental impact, closed material loop, and designing for full integration into the landscape are key components of a sustainable design. Now, this is an ideal state, and I know it is very hard to attain that ideal state, but if we try, we could. And in terms of truly sustainable product or a material, I would say it's very hard to define what would be a truly sustainable product or a material, but something which have all these salient features like minimum environmental impacts, it's fully recycled or fully recyclable, have integration into the landscape. And I know the bias will come out, but wood probably that close in that regard, although it has a pretty high environmental impacts in terms of logging, harvesting, and transportation, but it's less than that of, sorry Jason, concrete. It's okay.
So the battle lines are being drawn here.
Well, can I interrupt you to come back, because I realized I forgot to answer the question.
Certainly.
And so I feel like I have to defend myself now. No, but it's funny because when the question was asked about to find out, what could be a truly sustainable product. I mean, of course, so I deal with concrete all the time. So I think of concrete as being a material that could be truly sustainable. But on the other side, I kind of think of bamboo, and a kind of plant-based / wood-based material because of the rapidly renewable nature of a material like that can go through a harvest and growth cycle in about a 10 to 15 year process. That the advantages that concrete has is that it is a material that's recyclable. You can break it down, crush it down, and include it as new aggregate for a new concrete application, but you lose some quality there. So you may not be able to produce the same type of, let's say, an ultra high strength concrete that you could when you're incorporating the recycled aggregates. One of the other things is that we do use a lot of locally available materials because they're very dense. So transporting them becomes, a big issue on the economic side and on the, really linked to the fuel side of transporting them. So we use a lot of locally available materials, which is a plus, but we're also extracting aggregates, which are basically a non-renewable material over really most of our, any of our lifespans, obviously. It is an abundant material, so that's an advantage. But the biggest challenge I think that the concrete and cement industry have is that the production of Portland cement, the kind of raw binder material, the glue that holds all of the aggregates together, has a fairly significant CO2 negatives or a CO2 footprint issue with it. About 5 to 7% of the world's CO2 output comes from Portland cement production. So finding alternative binders or ways to capture that CO2 in production and sequester it or turn it into a new material is both a challenge and an opportunity.